Okay, so we are looking at the example on page 71 of our workbook in about the middle of the page. And this is our first example where they ask us to actually find the absolute maximum and the absolute minimum value of a function. Okay, by the preliminary example that we did at the top of this page, we discovered that there are really only two types of places that we need to look to answer this question. We need to look at critical points and at the endpoints of the interval that we're given. Okay, so notice they're asking us for the absolute maximum and minimum of this function on the interval from 1 to 4. So we can see the endpoints directly. They're just 1 and 4. Okay, those are generally given to you directly in the problem. Okay, so we're just literally writing down the two endpoints of that interval that they gave us. Okay, besides endpoints, we need to look at critical points. That means we need to do a little bit of calculation here. Okay, so critical points again are places where the derivative is either equal to 0 or undefined. Okay, so let's take our function and just to make it easier to take the derivative, I'm going to rewrite it. So x plus 3 over x is the same as x plus 3x to the negative 1 if we take that over x and just move the x into the numerator. Okay, and so we're going to take the derivative of that. We can do that just using the power rule. So the derivative of x is 1. And the derivative of 3x to the negative 1, if we bring that negative 1 down, we're going to get negative 3x to the negative 2. Okay, and before, when we took derivatives like this, we generally stopped at this point of the problem. But we're interested in actually figuring out where this derivative is 0 or undefined, so it's actually to our advantage to simplify in this case. All right, so I'm going to start by taking that x to the negative 2 and bringing it back down into the denominator. So 1 minus 3 over x squared. And then solving an equation is generally easier if we can get terms together. So I'm going to rewrite the 1 as x squared over x squared as a way of getting a common denominator. Okay, so instead of 1 minus 3 over x squared, we've got x squared over x squared minus 3 over x squared. That gives us a way to just combine this into one fraction. X squared minus 3 over x squared. That's equivalent to what we started with. It's just written in a little bit different of a form. Okay, and so it's critical points, again, that we're after. So we're asking, where is this function, okay, this derivative function equal to 0, and where is it undefined? And let's answer those questions separately. So the derivative is going to be 0 where its numerator is equal to 0. All right, so I'm going to focus on just the numerator and set that equal to 0. All right, if you take that, just add 3 to both sides. And now we need to take the square root of both sides, but remember, when you do that, there are actually two possibilities, a plus or a minus square root. So we actually get either the negative square root of 3 or the positive square root of 3. Okay, two possibilities there. And then we could ask, where is the derivative undefined? That's the other place where we might have critical points. Okay, well, that's going to happen when the denominator is equal to 0. Okay, so our denominator looks like x squared. And if we solve that equation by taking the square root of both sides, we're just going to get 0. Okay, so if we summarize where we're at in the problem so far, we've got 3 critical points, 0, negative square root of 3, and positive square root of 3. And we've got 2 endpoints. If you look back at the top of the page, x equals 1 and x equals 4. Okay, do we really need to look at all of those points? Well, remember that this is just asking us for the absolute max and min on the interval from 1 to 4. We don't care about any numbers that are outside of that interval. And notice that some of the numbers that we calculated are not in the interval from 1 to 4. For example, negative square root of 3. We can cross that out because it's outside of our interval. And you see another number that's not in the interval. 0. Okay, that's not between 1 and 4. And so really, all we need to look at are 3 points. 1, 4, and the positive square root of 3. Our absolute maximum and minimum are going to be at one of those 3 points. Okay, how do we decide which is where? Okay, well, what we can do in this situation is just to make a table and see what our outputs are one at a time. Okay, so I'm going to make a table of x versus f of x. And under the x, I'm just going to list the 3 numbers that we just looked at. Okay, so there was 1, that was one of our endpoints. There was the square root of 3. And then there was 4, our right-hand endpoint. We're interested in knowing what the output value is at each of those 3 numbers. Okay, so let's plug those in one at a time. Starting with 1, I'll do that calculation over here on the left. Okay, f of 1 is going to be, and remember, we're going back and plugging into the function f of x at the top of the page here. So 1 plus 3 over 1, that's going to give us 4. There's our first output value. Then we're going to move on to the square root of 3. Okay, you can maybe ask your calculator on this. This is going to give you, if you round it off, 3.46. Okay, and then finally f of 4. That's going to give you 4.75. All right. So where is our absolute maximum? Okay, well, to answer that question, just ask yourself, out of the 3 y values that you see over here in the f of x column, which one is the biggest? It looks like 4.75. That must be our absolute maximum. Okay, so f of 4 equals 4.75 is our absolute maximum. And what's the smallest number out of all of those? Well, that would appear to be the 3.46, and so that must be our absolute minimum. Okay, and those are the answers to the questions that they asked us. Okay, now they didn't ask us to do this, but again, it's instructive sometimes to look at a graph and just sketch the graph of the function and see if it appears that our answers are reasonable. Okay, so I'm going to sneak a little graph in here, and you are welcome to do this on your calculator and just confirm what I'm doing here. Okay, this is going to be a graph of the function that we started with, x plus 3 over x. Okay, and this is going to be just a very rough graph. Kind of has this sort of a shape to it. Okay, and I'm not going to bother to label the y-axis. You can maybe do this on your calculator and see. Notice that sure enough, it looks like our highest point is over here at 4. That's our absolute max. Okay, and our absolute minimum is somewhere about here. Okay, sorry, I keep... Okay, we've got an absolute min at that point. Let me scroll up again. And if our work is right, that should be about the square root of 3 and 3.46. Okay, and if you graph this on your calculator, it's going to give you a more